Good morning. This is Naz from NB Network Lessons. Hope you guys are doing okay. My today's topic is continuation of circuit analysis lesson 20 part 2. In my last lecture, I introduced you to op amp, which is also known as operational amplifier. And I introduced you and I showed you, what are the uses of it. Now we're going to look at step 2 and look a little bit deeper, okay? So, having said that, as we know that op amp does two things. It's a comparator and an amplifier. In this discussion right here, mostly I'm going to touch base on comparator. So what exactly does op amp does which is different than, say, transistor? Op amp can do calculations, comparisons, okay? So that's one of the difference. So let's look how. So if let's say this is a circuit right here, I've got V1 going in, V2 going on. V out can be presented as difference between V1 and V2. So we can have output as V1 minus V2. Let's look at another circuit. In this, we have V1 going into the circuit, V2 going into the circuit, and we want them to be added. So then the output is V1 plus V2. Multiply. So in this circuit, V1 is going in, V2 is going in, V out is being multiplied, V1 times 2. Now, another scenario. You have a circuit, okay? K is a constant, it's the gain. We have V1 going in, all right, only V1. And the output is K, the constant or the gain, times V, all right? So we can use this circuit to divide also by the constant. So let's say V1 is going in, V out would be equal to V1 over K, the constant. And there are practical uses of all of these in real world. So keep that in mind. Also, we can take derivative. So this voltage is going in and this is dV over time. So basically by derivative, what I mean is that change of voltage with respect to time, okay? We can do the integral also, okay? So in integral, what we can do is we can say the effect of accumulated voltage over time, okay? This is derivative. This is basically change in voltage with respect to time. This is basically accumulated voltage over the time, all right? So finally, we get to, how does op amp looks? This is a picture of an op amp. You have minus, you have plus, and you have plus, minus. This is the voltage source. This is where you will connect your AC source or DC source right here on these terminals. And then for input on the top one, you send non-inverted, okay? You send non-inverted signal, okay? And on the bottom one, this right here, you're sending inverted input. So whatever input you have, it's non-inverted going in, and on the second terminal, you have inverted input going in. And finally, if you look in integrated circuit, okay, now everything is basically shoved into integrated circuit. If you're looking at a circuit from, let's say you open up an IC, integrated circuit, or if you will see something like this. You will have transistors, you will have resistors, you will have, you will have op amps and so forth. So this is basically inside an integrated circuit. You will see all of that, okay? So basically what I'm trying to say is op amps are manufactured as integrated circuits. So keep that in mind. Op amps are manufactured as integrated circuits. One example which I can think of is LM741. It's a popular one, okay? So that's all I wanted to say in this lecture. Hope you like it. Watch this video maybe a couple of times. It'll make sense. So these are all basically uses of op amp which we can do to do mathematical calculations, okay? Now I'm going to dive further into op-amp in my part 3. So stay tuned. Thank you so much for watching. You all have a good morning, good day, have a blessed day, and I'll see you next time. Thank you.